my talk is not going to be quite as exciting as the previous talks because I'm not telling you about a product or a real framework that you can use. It's really just an idea, but I hope you'll still find it interesting and learn something in the next 10 minutes. So this idea is going to be a simple approach to collaborative text editing, where basically we're going to send operations to the server is going to apply them in order, and that's sort of it. We're going to skip the mathematical rules and complexity that come with more traditional approaches like conflict-free replicated data types or operational transformation. Start off just a little bit about me. So I'm a software developer at Common Curriculum. We're a very small company in the US that makes a collaborative app for teachers where they can plan their lessons. And it's not a local first app, but it does have optimistic updates where you make a change you see in your own browser immediately and goes to the server in the background. This uses an in-house sync engine, which is essentially event sourcing over MongoDB. Simultaneously, I've been a PhD student at Carnegie Mellon University for the past 6 years. And really, the goal of my research has been to make progress towards free and open source collaborative software in the same style as open source Linux desktop software. And really, the reason I'm interested in local first is because maybe if we take out the cloud server as a core component of every collaborative app, that'll let open source developers without many resources or money deploy their apps and then just sort of not worry about it and not have to raise a bunch of money to pay these cloud servers. Towards that goal, I've mostly focused on the data and conflict resolution problem, especially conflict-free replicated data types, which you can read about in my blog. In particular, there's a blog with a long form of this talk there that you can look at later. What am I talking about now? So my experience from thinking about CRDTs for 5 or 6 years is that they're a lot of fun, especially for someone like me with a math background, but they're pretty hard to use in practice. There's these correctness rules you have to satisfy. You're sort of limited in the operations that you're allowed to perform on your client devices. And because of these correctness rules in particular, you're often limited to using libraries that someone else wrote who's an expert in these things. And then you get sort of constrained by whatever design decisions these libraries made. For example, it's hard with a lot of CRDT libraries to do a partial loading where you have some state in memory and some still on disk. Not that this is hard in an algorithmic sense, but just it hasn't been built into these libraries, and you'd have a hard time building it yourself without first becoming an expert. So because of this, I've been really thinking for the past year about a different approach to conflict resolution called server reconciliation. This comes from first-person shooter computer games. I learned about it from Replicache. I believe it's used or will be used by Zero and LiveStore, so I was sort of hoping they would tell you about it already, but I'll recap it later when we get to it. But even sort of advocating server reconciliation since last year, I thought that you did still need these fancy algorithms like conflict-free replicated data types or operational transformation for text editing in the style of Google Docs. Until I saw a very intriguing comment. It was just a comment on Hacker News from someone named Wim Kool's about the timer IDE, which is still in development, and how its collaboration worked. It described an approach to text editing which wasn't a CRDT, but was more like server reconciliation. Just found that very interesting, kept thinking about it, and sort of ran with it. And this talk is basically an elaboration on that idea. So, what is the approach? Let's say you're typing in a document like a Google Doc. You make some change, like you insert the word Fox here, and you need to send this operation to the server and tell it, hey, I want to insert this word here. Whereas here, it's after the n in brown, but maybe we'll refer to it using, I don't know, an array index. Say, insert this text at index 9. We send this operation to the server. But what happens? Someone else is looking at the same document. Concurrently to my edits, they send the operation insert quick here. And that arrives at the server before mine. So now when the server gets my operation, inserting at index 9 isn't really correct anymore. We need to insert at index 15 instead, still after the n in brown. So what are we going to do? Let's not use array indices. Let's just use, here is a character referred to by a UUID. So we assign a UUID to each character. When we say insert here, we say insert after the n in brown, referred to by its UUID 207, etc. And the server just does that. And then even if Alice's operations get to the server first, we're still doing the right thing. We're inserting the text after the n in brown, identified by its UUID, without the server having to do anything particularly clever. OK, so what do we need to make this work? Well, we need a way to store these UUIDs for each character. This can be as simple as just an array of pairs, character, comma, UUID, except that actually we should also remember the old characters' UUIDs. Even if a character is deleted, we want to make sure that I send an operation that inserts after ID 591, et cetera. If the server's deleted that character by the time my operation gets there, we still want to know where it belongs. So we'll remember these with, you might have heard it called a tombstone in the CRDT literature. That's really all we need. You can implement this pretty minimally. I have a reference implementation in 250 lines of code. I think you could do smaller if you take away all the helper methods. This is something I encourage you to try yourself if you find it interesting. I do also have a small library that does this in a more optimized way. Like obviously, we don't actually want to store a UUID for every character, so it has some optimizations like that, and also built-in persistence. Okay, so that's sending operations from clients to the server. What about then from the server back to the clients? In particular, we have this tricky case where you have some pending local operations that the server hasn't acknowledged yet. Instead, it gives you a new concurrent operation from a remote user R. So now we want to update our local state to incorporate both this remote operation and our pending local operations. And here's the part where we sort of have to merge these changes in some way that has consistency rules. So now we have to use a CRDT write. Oh, well, actually, we don't have to. This is where the server reconciliation comes in. Johannes referred to it as event rebasing. Basically, we just rewind to the server's old state, add the new remote operation, so we're up to date with the server, and then rebase our pending local operations on top of it to end up in the state that the server will be in once it receives our operations anyway. And you can do this without having any rules about the operations that say they need to commute or transform, et cetera. Okay, so that's the whole approach. We still have a few more minutes, so why do I care about this approach? Well, for me, simplicity isn't a goal itself. If you start with a complicated algorithm, then when you make your first prototype implementation, it's going to be more complicated, like 5 times more complicated. And we try to use it in an actual app, it's going to be even worse. So let's start simple so that we can actually make an app in the end. In particular, this approach, I hope it's easy enough that if you're feeling confident, you can go home and implement it yourself instead of spending several weeks reading academic papers about CRDTs. And then once you have your own implementation, you can do what you like with it. You can, maybe add fancy operations, not just insert or delete, but, change this word if it's still there. You can add partial loading. You can add suggested changes inside of Google Docs. So I'm not saying that I've implemented these features or even that they're necessarily easier than with a CRDT, but it's just that if you own the implementation, you can do these things yourself instead of either waiting for someone else to add it to a library or becoming an expert in someone else's library and then doing it. Okay, so this is Local First Conference. I've been talking a lot about Essential Server. Depending on who you ask, that's maybe not okay. So let's see, how can we make the server optional? So there's a variant of this server reconciliation rebasing strategy where we don't really, instead of using a server to put the operations in order, we just let the clients do them themselves. So it's again sort of like event sourcing where we have a decentralized agreement on what the order of events are. So users put their events into this little bubble, they talk to each other, and they come to an agreement on what the real order of events should be. They just apply the operations in that order. And you can do this without consensus. You can just use Lamport timestamps or some other logical clock. So in particular, if these operations are our insert after ID operations, we get a working approach to decentralized collaborative text editing. Okay, this sounds like a CRDT, right? Yes, it is technically a CRDT in the sense that any approach to decentralized text editing with eventual consistency is going to be technically a CRDT. It's sort of a degenerate one because you can put whatever operations you want in this log, and they'll still come out consistent. In particular, if it is a text editing CRDT, which text editing CRDT is it? It's equivalent to an existing one called RGA, or causal trees, in the sense that if you use this technique, you'll get the same order on characters, the same text document as you would if you used a literal RGA implementation. Likewise, if we add formatting operations in sort of the naive way, we say, I want to make the text bold from here to there, where here and there are both expressed in terms of character IDs, you get a CRDT, which is very similar to paratext in the way it resolves conflicts between different editing spans. Okay, I mentioned putting operations in order by Lamport timestamps. This is actually a little weird in that if you have 2 concurrent branches, like one user working offline and another user working online, then when you go to merge their changes, they will be interleaved. It's like if you did a git merge and it decided to make an edit history with every other commit. It's just a property of Lamport timestamp. So you can do other things. You could do a literal git merge, some sort of manual protocol for describing how to combine your branches, or even an automated approach. If you do that, and again, if your operations are these insert after operations I described earlier, then you get the result equivalent to the fugue text editing CRDT, which has these non-interleaving guarantees built in, where you say if 2 people are typing in the same place at the same time, they won't interleave our characters in the same way that we're not interleaving these operations. Okay, so if you remember anything from this talk, it's give each character a UUID, tell the server insert after this ID, and then just use server reconciliation to update the other clients. And if you're feeling ambitious, implement this yourself, start adding cool other features, add formatting, make it decentralized. Yeah, try it at home.